Let's say now this object makes a U-turn. He's turned back. Okay, now he's traveling towards left. Even though his current position is towards the right of the mean position, he's moving towards left. So what will be his direction of velocity? It's going to be negative. Okay. Let's say this object continues to move towards left and has reached the mean position, is not at rest. What will be its current velocity? It's going to be negative. Velocity, it's going to be negative. Let's say this object continues to move towards the left of the mean position and is traveling in a direction which is also towards left. What's the current velocity? Negative. Okay, here you see. Is it clear now? Is it clear now? Okay, let's say that the object continues to move towards left and has now reached a new position, which is position number 2 towards the left of the mean position. What will be the current velocity? Since the object is still traveling towards left, the velocity will be negative. Let's say now the object makes a U-turn and moves towards point number 1. Even though the current position of my object is towards left of the mean position, the direction of travel is towards right. What will be my displacement or my velocity? My velocity will now be positive. Okay. And let's say the object continues to move towards the mean position in the direction which is towards the right, the velocity will continue to be positive. Good, Tahir. Good. You are following. That is very nice. I would like you guys to also comment with your answers, since I'm continuously going to be asking certain questions. So it will be good to see your response over here, so just to know so that you guys are following. Okay. So this is what velocity is. Okay. So when we talked about displacement, for displacement, what we were concerned about was not the direction of travel. We were concerned about the position of the object with respect to the mean position. Whereas now for velocity, I'm not concerned with my position. I'm concerned with my direction. So that is how we have to actually go ahead and get velocity its direction. I hope I am clear. Has everyone understood this much of the topic regarding displacement and velocity and its direction? Guys, have you understood? Hello, people. Have you understood? Okay, good, Tahir. I hope Rizwan is also with you. Sufyan, I think, is still having some catch up, maybe. So, Mr. Ketchup is still trying to connect to us. Can we ask Mr. Ketchup that how can we send him the link again? I've already invited him. I don't know what's the issue. Okay, so Rizwan is also joined, okay, and he's saying that he also understands. Okay, that's cool. Okay, we'll probably also try to go over it as a brief summary in the next class that we're going to have. I just didn't want you guys to waste your time, because I know it's rained a lot. Even though I was there at Inspire an hour back, the roads were not that bad, but I understand many of you might be coming from far away, and considering some certain reservations that even parents might have in sending their children out in this weather. And also it can rain again, and in case if it rains again, then obviously it's going to be very bad for you guys to return home on time. Okay. So moving on, the next physical quantity in line is acceleration. Okay. So acceleration again is a vector quantity. Okay. And how would you define acceleration? So acceleration is defined as the rate of change of velocity. This is one of the very important definitions. Okay. Acceleration is defined as the rate of change of velocity. Okay. So therefore, if it's the rate of change of velocity, how would I define? How would I give its equation? So the equation for acceleration will be given as acceleration is equals to v minus u over t, where v is your final velocity, u is your initial velocity, and t is the time over which that velocity changed. Now, if you are having acceleration, that is the acceleration, the guardian acceleration. If you're having that acceleration, then what would happen? Your final velocity would definitely be more than your initial velocity, telling you that there was an input of some force, right? But force we'll be talking about in dynamics, but just try to understand this concept. If your final velocity is more in magnitude than your initial velocity, we are accelerating, right? Let's say we are decelerating due to some negative effect. Let's say brake laga di gaadi ne or whatsoever. Now my final velocity will be less than my initial velocity in terms of magnitude. So therefore the acceleration would be probably negative. I hope you guys are clear with this, right? So acceleration is defined as the rate of change of velocity. It's given by the equation A is equals to V minus U over T, where V is your final velocity, U is your initial velocity, and T is the time over which this velocity has changed. Okay, that's SI unit of acceleration is meters per second square. Now, since acceleration is a vector quantity, the direction of acceleration is what really matters. It's very difficult. So, just for the sake of an argument, or just for the sake of the exam, what would you write down in your exam? If somebody is saying define acceleration, you're like, okay, acceleration is the rate of change of velocity. Cool. Let's say this question was for 3 marks. You will say, for 1 mark, you can write down the definition. For the second mark, you can say the SI unit of acceleration is meters per second square. What will you do for the third mark? For the third mark, you have to tell the direction. What will be the direction for acceleration? Now, it's not as simple as it was for velocity or displacement. No. Here, the direction of acceleration is actually the direction of the change in velocity. So, as I clearly mentioned in the beginning of acceleration, discussing acceleration, that if the initial velocity is less than my final velocity, rather I would say if my final velocity is more than my initial velocity, then probably my acceleration is positive. So yeah, it's not always, because I can give you later on, I'll give you some certain examples in which this will not be the case. But then again, you guys need to be at the current level, just understand this, that the direction for acceleration is the same as the direction for change in velocity. Okay. Moving on to certain more definitions that are in your syllabus, and one of them is the definition for average velocity. So how would you define average velocity? Or sorry, rather not average velocity, if not, let's talk about average speed or average velocity, more or less the same thing. So how would you define it? So average speed or average velocity is basically defined by the equation of total distance traveled over total time taken. If I want to move from point A to point B, okay, it's not necessary that if I move from point A to point B, I will be traveling with the same constant speed. Impossible, right? You guys drive and you guys know कि रास्ते में कराची में तो वैसे भी ब्रेक ज़्यादा लगती है. Okay, you cannot travel with the same speed. Okay, so how would you define the average speed? It's defined as the total distance traveled and the time taken to travel the total distance. तो उसका आपको average speed पता चल जाती है कि आपने point A से point B पे जाने के लिए total कितनी speed से travel किया. ठीक है, and I hope that makes sense. So yeah, other than this, I think there is nothing much left for the definitions part. The next important part that we have in hand is actually the equations of motion. Okay, so I think all of you are on your laptop, because I would be maybe sharing some screenshots as well, because I have the notes copy in front of me as well. Okay, so Moise is also having issues. Okay, please ask Moise to come onto the computer, and probably that's how it's going to work. I'm not sure. Okay, so moving on. Let's see if I can share the screen, because I have my notes on. And let's see if we have the sharing screen option somewhere. I had it a while back. Okay, I think it won't have a problem if you are on your phone. I think as long as you are able to view it, there won't be any problems. By the way, what are you guys doing at Sir Mobi's house? Like, I had my class scheduled. What are you guys doing there? Just to know. Seriously. Come on. And Tahir, please, you and Moise, you both need to specifically work harder. Okay, you guys need to work harder. Because currently, I'm not getting a very good response. I'm getting an okay response. Okay, so that's not making me less confident about you guys appearing in your exams. Try to be a bit more,